Welcome to the sixth lecture of binary hacking. Today we're going to be actually looking at the code and how to code up the WAV file parser. Because last week we were mainly just looking at how things were stored in memory. So this week we're actually going to look at the code, and we're going to look at how to implement the load and write functions. So I'm going to share my screen. So yeah, here today we're learning about reading and writing binary files. So today, what you will need to do before you leave is implement all the sections that are marked with to do in the starter code. And you can get the starter code from last week. And then once you implement everything, you should be able to open up tests/secret.wav, and it'll display some fancy message for you. So then go and just pick out what your favorite message was from this file and put it in Discord. Okay, so yeah, once again, so this is the WAV file format. And so we can see it starts with a chunk ID and chunk size and format. And if we want, we can open it up. So yeah, so here you can see a WAV file. And yeah, so it starts out with the letters RIFF, just as it says, and then it has the chunk size, which is right here. And then it has format, which is WAV, you can see here. And it has a FormatChunk here, and then a DataChunk right here. FormatChunk, DataChunk. So the question is how can we go and convert this structure into a class, like a C++ class? And so let's actually go and start writing it out. So the first thing that I noticed is the file is made up of a bunch of these chunks. Like you can see chunk ID and then subchunk and then subchunk 2, and then maybe we might have a subchunk 3. And so in chat, or you can unmute yourself, can you tell me something that you notice that is similar, that each chunk shares?
Well, you're asking what's similar between all those blocks stuff?
Yeah, if we make a class chunk, so just a generic chunk, and then what should we put in here?
So the byte size, I guess.
The size, yeah. So here we can see it says chunk size. So subchunk 1 size, subchunk 2 size, chunk size. So yeah, I think size is awesome. So and so we can see that it's a 4-byte integer. So we can say unsigned int size 32 t, and so chunk size. Cool. Okay. And so boom, now, we can see that they all have size. Another thing that I noticed is all of them have this chunk ID. So no matter what chunk you are, all chunks are going to always have this chunk ID. So we can say okay, so character array chunk ID size 4. Okay. Cool. So if we wanted now, we could represent this file as a bunch of chunks. But we could say okay, so this is a chunk with the ID of RIFF and the chunk size of the entire size of the file. And then here's the format chunk. So this has an ID of format and size of the format. And then data chunk, it should say data here, and then the size of the data. Okay. Is that clear?
Yeah.
Okay. So, but now let's say let's go and actually kind of implement this data chunk. So, so let's write out the things that the data chunk has. So it's going to be very similar to this chunk class, except it's going to be data chunk. And yeah, so look, we see it has the chunk size and it has a chunk ID. So we're almost done. So all we need is just one more item. So what is that last item? Do you want to help me out with it?
Would that data, that data block, would that just hold all the information of whatever that file has in it?
Yeah, exactly. So yeah, it should just be a big long just buffer or array of all
yeah,
like a byte array. So how do we make a byte array in C++? And we would just write it uint 8. And this 8 means just 8 bits. So this right here is just one single byte. Data is now one single byte. But if we want it to be an array, then we could do something like this. Or what probably better is if we just make it a pointer array. So, okay, but look at this. So this is kind of unnecessary code because so we have chunk size, chunk ID, chunk size, chunk ID. It'd be really cool if we could just like have this like have a chunk or something. Or like we want this to take on all the properties of this chunk. So do you remember how to do that?
Do you call that class in there?
So you could do that. Like or something. Yeah. Is there a better way? Inheritance. So now this says, so DataChunk is a chunk, meaning now DataChunk has all of these attributes, but then it also just has like an extra attribute. When we say public chunk here, :public chunk, we basically say, okay, just copy and paste everything that's in here and now put it here. Cool, cool. Okay, so now let's make the class for the format subchunk. Do you want to walk me through it? So format chunk. So should this extend anything? What do you think? Yeah.
Yeah, I think you need to take the ID and size, which we already have.
Yeah. So let's call public chunk. Let's give it public chunk. So now this format chunk has all of this stuff. So just immediately, boom, by saying public chunk, now we also give it this stuff. So that's like in pocket. So now when we go to this green stuff, we can just leave off this chunk size and this chunk ID. So now all that's left is just all of like audio format, num channels, sample rate, byte rate, byline, bits per sample. So let's go and do that really quick. So we need a 2-byte integer for audio format. So how do we write that?
Would that be uint 2byte 16?
Yep.
Underscore t.
Audio format. Yeah. And then audio channels would be the exact same thing, right? Just audio channels. Okay. And then what's the next one? So it says sample rate.
Sample rate.
So what do we?
Now, yeah, that would be uint 32.
Yep.
Or 4 bytes. Yeah, 32.
And what about? So then there's byte rate, and it looks like it's going to be probably the same thing. Byte rate, and then block align. So what's the size of block align?
Yeah, that would be 16.
Yep.
Yeah, because it's 2 bytes. That's 16 bits.
Cool. And then last one is bits per sample.
It will be the same size, some 16 bits.
Okay. Cool. Okay, so we now have our structure for a WAV file. So we have. Oh, actually, no. Wait, we're super close. Actually. So next, we have one more type of chunk that we need to deal with. What is it? So we did the green and we did the orange one. So now we need to do what? Which one?
You do the RIFF chunk in the very top.
Yeah, exactly. So this is kind of interesting because we kind of wanted to have both this and this. So that's actually not allowed. But look, so we could almost imagine that this like purple chunk has, so it has a few things. So it has chunk ID, it has chunk size, it has format, but then it also has this green subchunk, and then it has this orange subchunk. So we could write it out like that. So we could say this, let's just, so we say that it needs to have a chunk ID and chunk size. And then it needs to have format.
Wait, for this one, why aren't we doing the inheritance for this one?
We are. I was just.
Oh, you said okay.
Yeah. So exactly. So you see right away. So since we are like like we don't really need to include this because we already have it up here. So yeah, so we can just like save on code and inherit. Cool. Okay, and then now, so yes, we say it has car format, and then what should the next thing that be called? What do you think? So I'm gonna blow your mind a little bit. So we can just say that this includes the format chunk, and so now we can say that this is format.
Oh. So we just call the whole format. Okay.
Yeah, because
so that.
It's
so that format, that purple format block, that contains all the other blocks, the greens and the orange stuff.
Right. Yeah.
Oh wait.
Yeah.
Okay. Interesting.
Like yeah, this is a weird problem that like comes with teaching inheritance. It's like the is a has a problem, where it's like you said at the very beginning, we're like, so we could, instead of just saying like public chunk, we could just like remove this and just have this have a chunk. So we could just say that, but we don't really want to say that DataChunk has a chunk because DataChunk is a chunk. So it's almost like this is like completely equivalent to doing this, but really it doesn't make as much sense. Whereas a RiffChunk has a format chunk and it has a data chunk. Because although, yeah, technically it does have like byte rate and block align bits per sample, but really it has this entire green section and it has this orange section. Yeah.
That's crazy.
Yeah. Yeah. So this is a problem with is a slash has a in inheritance, where you could make something extend some class, or we could just make it like have that class, like right here. So yeah, RiffChunk both extends a class and also has a class. So yeah, kind of weird stuff, but cool. Okay, but unfortunately, this is not how I decided to implement it. It's very, very close. However, so this WAV file format is actually very outdated because, so I wrote it down here. Yeah, so however, actual WAV files have many more subchunks. Subchunk chunks. That's funny. They have many more subchunks because yeah. So some WAV files like don't just have data and don't just have format. Some of them might have like metadata. They might say like who the artist is and like what studio produced it, or maybe like the time, the amount of time the song takes up, or things like that. And so there's actually quite a few other chunk types. So I wrote a couple here like Vex, XL, or XML, and there's like a small list of them, but there's like a bunch of other random things. And yeah, so that's kind of confusing. So what I decided to do is I decided to actually kind of, I created a new chunk type because I didn't want to just like, yeah, so Vex is like a really common thing. So I could say like text chunk, and then I could say like public chunk, and then I could have it like have all the things that a Vex has, like string artist or something, or string whatever. But instead, just to like make it easy on myself, I decided to just make a miscellaneous chunk. And this miscellaneous chunk just has just random data in it. And then later, if we decide to use this data, then we can just like pull it out of this like big block of data. So miscellaneous chunk just kind of like, yeah, holds like whatever random data we happen to pull out of the file. Yeah. But, so how does this change our RIFF chunk? So our RIFF chunk, so we said it had a format chunk and a data chunk, but now it also needs to have MiscChunk. So what should we put here? What do you think?
Would that just would you just call MiscChunk? And
like that?
I guess for the variable
like something like that.
chunks, yeah. Guess so, yeah. And the only thing that's going to be calling is that one array.
But what happens if you, oh, yeah, what happens if you have like 10 miscellaneous chunks?
So if there's like 10 like parameters inside that miscellaneous chunk class.
Oh, okay. So you're saying like maybe have like a few different of these, like data 1, data 2, data 3 sort of thing?
Yeah.
Um,
If you call it in that chunk, would that call like all of those? Actually, yeah, it will.
So yeah, I think a better way might just have like an array of miscellaneous chunks. So we can do that. And so now we have an array of extra chunks.
Oh yeah.
Yeah.
Okay.
Or we can do vector if you want, but I don't know. Just for now, we can write. Or if we wanted like an array of extra chunk pointers, and this is actually how I have it, is I have extra chunk pointers. But okay, so that now we fixed our RiffChunk. But now, what can we do about our DataChunk? So let's look here. Can we edit our DataChunk now? So look, it has the exact same inside as our MiscChunk. Our MiscChunk and DataChunk are identical. So if we want to save on some code, what can we do? So it's either going to be probably like MiscChunk extends DataChunk or DataChunk extends MiscChunk. Which one would you say makes more sense?
I think.
Like, should we say?
I think DataChunk should MiscChunk. Yeah, isn't MiscChunk? That's like just our bag of eggs, and you want to pull from that bag.
Right, exactly. Our MiscChunk is basically just a bag, but DataChunk is like also a bag, but it's like a fancy bag that holds our sample data. But our MiscChunk isn't just a fancy bag that holds our sample data. It's just like an ordinary bag. Yeah. So it's better to have like DataChunk is like our super official DataChunk that holds samples, and our MiscChunk is just like an ordinary kind of bag. Okay. Cool. Right down here, and so how do we need to edit this file now, or this class? So look, DataChunk has everything in MiscChunk. So what do we need to change about this?
Could you just delete that parameter?
Yeah. So
it's already.
Yeah. So it's literally just empty. And that's what I have on the website right here. Oh yeah, I guess. Yeah, so struct DataChunk extends miscellaneous chunk, and then there's nothing. Kind of thing. Yeah. Our MiscChunk has this. All right. Yeah. Does that all make sense?
Yeah, that makes sense.
Excellent. So now this is our structure for the WAV file format. So yeah, we have everything is made up of chunks, and we have FormatChunk, which is a chunk. We have miscellaneous chunk, which is a chunk. Our DataChunk is a miscellaneous chunk, and our RiffChunk is a chunk, but it also has inside it a DataChunk and a FormatChunk and an array of extra chunks.
What does the double asterisk mean for the MiscChunk again? You said it was like you say an array of pointers.
Yeah.
Okay.
Yeah. It means it's a pointer array, and then this means it's an array of pointers. Or this could be like a double, like a 2D array if we wanted.
Okay. Yeah, 2D arrays.
Or like a 3D array, or like a 2D array of pointers. Yeah. Cool. Okay. So now let's. What's the next thing? Okay. So I'll now open up the code. So here's the starter code. So we can see riff.h. Yeah, so we have struct chunk. Struct chunk has an ID and a size. Miscellaneous chunk just has data in it. We saw. Format chunk has all of these things that we were talking about. Data chunk has nothing in it. It only just has these methods. And a riff chunk has a format, has a data chunk, and a format chunk. And then here I have a vector of pointers to MiscChunks. All right. So yeah, hopefully this file makes a lot more sense now. It's kind of a long header file because I have a lot of comments in here too. But yeah, okay. So the next thing I want to show you is, let's just try like writing the code for this load function. So here is struct chunk. So if we go to this load definition, so this, let's just delete that and let's write it right now. So this load function, so it gets passed in a buffer, meaning like a file. So it gets passed in a file, and then also the size of the file. And then based off of this, we should load in all of this data into the chunk members. And if we remember, so the chunk members are just chunk ID and size. So yeah, all we need to do here is just load in, so write that out. So load in chunk ID and chunk size. Okay, cool. So what's our first step? So if the buffer starts right here at 0, so what should we do first?
Load in, you'll load in the ID.
Yes, yeah, we're loading in the ID.
Yeah.
And so we have this buffer, and this buffer right now, where did I say this is pointing to? Like which, what's the word for like the thing that's pointing to?
Is it at buffer 0?
Yeah, chunk ID at buffer 0, yeah. So it's already pointing at chunk ID. So what we can do is call this memcopy function. So memcopy. And so it goes destination. So what's the destination? So it should be like this.
For which one?
For chunk ID. So
is it 0?
So this is the destination of where we're going. So the destination starts out being this chunk ID, right?
Oh, okay.
Or just chunk ID, yeah. So we're loading it into chunk ID, and then what's the source? Like, where is it coming from?
It's coming from the buffer, right?
Yeah, it's coming from the buffer. So we can just write out buffer, and then memcopy. Then the last thing is how many bytes that we need to copy over. So if we look at this, how many bytes do we need to copy over?
4 bytes.
Yeah, 4 bytes. Cool. Okay. So now let's do the same thing, except instead of chunk ID, it'll be what? What's the next thing that we need to copy over?
The chunk size?
Yeah. Chunk size. And so what's the source?
It would also be the buffer.
So very close, because so remember pointing at 0. And we want it to point at
it should be increment.
Exactly. Yeah. So what should we increment it by?
Should it be like buffer plus, I'm guessing?
Oh,
yeah, buffer plus 4.
Yeah, buffer plus 4. Cool. Okay. And now what how many bytes do we need to read in?
And yeah, it would also be 4 bytes.
Yeah. Cool. Cool. And are we done? Oh, why are you upset?
Oh. I think so. Like, I mean, unless you want to count the format, that format block.
So remember last week we were talking about endianness. And the problem is, so what we did is we took this file, and this file is in little endian, but then we just immediately just went and copied it into our computer's memory. Like we didn't care about endianness at all. So now we need to make sure that the endianness is correct. So we need to convert the endianness.
Okay.
You remember that?
Yeah.
Okay.
You said just to like copy it, and then you said do like all the conversions at the very end.
So your bread and butter of copying in data should always be like memcopy, and then it should be like endian swap or whatever, or like something to convert the endians.
Okay.
So, and then here, so I showed this last. Here is the file that I created for endian conversion. So which one of these functions do we need? Little endian to host, big endian to host, host little endian, host to big endian. So remember, so the file we're currently working with is little endian, and we want to convert it to the host. So which one should we use?
Wait, do we know which one we want to end up with? Is that the file, which is the little endian? Wait, no, we're converting the little file, right?
Right, yeah. So we are taking the file in, which is little endian, and we are trying to convert it whatever our machine is.
And we want to, so we wanted to go to the host.
Mm-hmm.
So that would be the very last one.
This one?
Yeah, there's two.
Yeah, okay, cool. And so there's...
Oh, is one of them for like 32 and that's 16? Is that like the sizes?
Exactly, yeah. So
okay.
Which one should we use?
So since these are 4 bytes, we want to use 2.
Yeah. Cool, so now we say so chunk. Cool, okay. Cool, and then generally, every time you run this load function, you generally want to print out or you want to return how many bytes that you loaded in. So here's kind of a weird thing. So how many bytes did we load in? So it's like 4 and then 4. So how many bytes did we load in?
If they're both 4, I guess 8 bytes.
Yeah, kind of, right? But here's the thing. So this is a chunk. So let's look at like the size of this chunk. So this chunk size is actually, it's going to be 16, meaning like if we were to add up all these numbers, it would be 16 and plus this 8. So so when we loaded in with the chunk, we loaded in these top 8 bytes, but then we kind of just skipped all of this data. So yeah, when we did load, we only loaded in these 2, and then all of these guys were just kind of like ignored. So honestly, like I would say instead of just returning what we've read, we should probably return the entire size of the chunk.
Oh, okay. Yeah. Just return, even though we didn't use those last, we still have to return them.
Yeah, because like, yeah, what if you wanted, yeah, like what if you wanted to get the size of the chunk? Because yeah, like what if you wanted to get like a bunch of chunks right after one another? Like you didn't actually care about the contents of them, but you just wanted to get a bunch of chunks one after another. That way you could just go and run this function, run this load function, and immediately just get the size. And then like increment like the buffer by that size, and then load, and then get the size, and increment the buffer by that size. Yeah, so generally it's better to work with probably the entire size of the chunk. So what would be the size of the chunk here?
Would you return chunk size?
Yeah, like super close. So that like makes sense totally, and that's what I would have guessed. However, chunk size is actually not, chunk size is actually like 8 less than the size of the chunk. So yeah, it says here. So this has the, no, that's bad. So this is the size of the rest of the sub chunk, which follows this number, or it's the size of the chunk, which follows this number. So meaning like if you have this data chunk, so let's say you had 10 bytes of data here. So you'd imagine your chunk ID, that's 4 bytes, and then your sub chunk size, that's 4 bytes, and then data is 10 bytes. So we should imagine a total size of 18. However, our sub chunk 2 size will only show 10 because that's the size of this guy. So what we need to do is we need to say returns chunk size, then plus 8, because that's like how many bytes like the sub chunk like ignored.
Okay.
Yeah, it's a little bit confusing. Moral of the story, just like every time you ever return size of chunk, like just always increase by 8. Yes. Okay. Cool. Okay, and now let's quickly do the write. So the write is going to be very similar to to the load. So here this time we're given a buffer to fill. So we weren't given a buffer. Last time we were given a buffer so that we could like fill our data. This time we're given a buffer so that we can fill this buffer. So let's look up here. So what's the first thing that we should do? So probably mem copy. What should we copy? So what is the destination? So remember, we're trying to fill the buffer. So we probably want the destination to be buffer this time.
Buffer, okay.
Yeah, and so what would be the source?
Now being chunk ID in chunk size, or yeah. So in this function, we're taking that previous chunk and then we're just filling in this new buffer file.
Mm-hmm. So
what is the purpose of that?
So this means, so like, let's say we're given a file. So we load in the file so that now our, like all of this data here, this chunk data and all this MiscChunk data is loaded in. So now we have all of this data that's loaded in, and now we can go and run some algorithm on it, or we can edit it or put it in an app or something. Now it's really easy to edit. But now let's say that we want to render our file, or we want to actually export our file or save our file. So now we write this. Now we do this write function. So this write function will add it to a buffer. And then this buffer can then like output it to a file.
Okay.
Yeah, so I guess, yeah, something I skipped. So here is the load function for the wave file. So remember, so here's like all the chunk data. So this is the RIFF header file. But here is the actual like wave file. And I can show you the header for that. So the wave file, all it has, the only thing that this wave file has is just the RIFF chunk. So just like the purple chunk right there. So it has like all of this data basically. So when we call load on it, we pass in a file, like a file name. And then when we write to it, then we also pass in the file name. But write gives us the file back, but load takes the file and puts it into this class.
Okay.
Yes. So yeah. Does that make sense? Why? Yeah. The purpose of like load and write now. Yeah.
Okay. Yeah. So we're loading from that, and then I'm guessing that second one is a write. So we write back to that file.
Yeah. So yeah, write.
Okay.
Wave data to a file, loads data from a file. Okay. So going back to the write. So the first thing we do is we copy the chunk ID into the buffer. And then what's the next thing we do? So it's going to be another mem copy. So what is the destination this time?
The destination would be buffer.
Yeah, or close.
Buffer plus
4. Yeah. Because we like already wrote to these 4 locations right here. Yeah, and then what's the...
So it has a +4. Would the source be chunk size?
Yes.
In chunk size. Yep. We're calling that as a pointer, right?
Yes, because mem copy only deals with pointers.
Okay.
Yeah, and so now we need to do one more thing. So what's that thing that we need to do?
We had to convert it to endian to host.
So that was what we used for load. So what are we going to use for write?
Is it still converting from little endian?
So we're currently either in big endian or little endian. We don't know. We're in the host.
Oh wait.
And we need to convert.
So should we now? Do we need to go from host to little endian?
Exactly, yeah. So close to little endian. Yeah, cool. And what I might do instead is I might call this actually before this. I'd say like chunk size, or let's say, here's this. You want to say to T10. And now it's a 10. So yeah, so all we did is we just converted the endian from host to little endian and then loaded it into the buffer. And now what do we return?
Would it be return chunk size?
Chunk size plus,
Yeah, chunk size plus 8.
the exact same thing. Yeah.
Okay.
Cool. All right. And so what's really cool about this is now, so here is the load file, or the load function for miscellaneous chunk. So what were the things that the miscellaneous chunk had? Do you remember?
It was, you just had like a single pointer array with, yeah.
Yeah, exactly. So we have data. Yeah, we're calling data equals new int, or new byte array size, chunk size. Cool. And then here we can see, so we get the size right here by calling the previous load function. So we're calling this function that we just implemented right here. So yeah, so we pass in the buffer and we pass in buffer size. And so now what this will do is this will initialize. So this will init our chunk ID and chunk size. So by just calling this function, we don't even need to worry about dealing with chunk ID and chunk size because we already wrote the code up here. Yeah. So what's the only thing that we need to deal with?
Would it just be one pointer data?
Exactly. Yeah, so let's do that. It should be pretty easy. So just mem copy. Oops. So it's the source.
The source would be data. Yeah. So we're writing to data.
We're writing to data. So the destination is data. And what's the source?
Is it buffer? Yeah, buffer.
Close. So buffer and what?
What? It's buffer plus.
Let's go and look at it. So let's assume that. So let's say, yeah, we're trying to load in this MiscChunk. So this MiscChunk, let's say we're given the buffer right here. So that our like offset, our buffer starts at 36 right here. So first we go and run this load function. So this load function gets subchunk ID 2 and then gets subchunk 2 size. So now our data actually starts at 44. So it should be like buffer plus some amount in order to get to the data. So what is that?
It'd be buffer plus 44.
So not 44, because buffer, we're saying that buffer here is equal to 36.
Oh, buffer starts at 36. Buffer plus 36.
So if buffer is currently equal to 36, but we want to get to 44.
Oh.
Say that again?
Wait. Yeah, buffer plus 8.
Yeah, exactly, yeah. Buffer plus 8. And so, because remember, 8 is the size of the chunk header. Or yeah, so it's the size of the ID plus like the size of the size. Yeah, so
yeah, you're right. I didn't notice that.
Yeah. So now the next thing, so now we need to say how many bytes to write. So how many bytes do we need to write here?
Yeah, the data didn't have a size to it.
So we can see here that here's the data, and we're making a new array, and here's the size of it.
It's a chunk size, so it could be Yeah, so can we just,
Yeah.
yeah, our size is chunk size.
Right. Yeah. Because chunk size by definition is just the number of bytes in data. So we're saying copy just everything in data. Cool. Yeah. So that's all we need to do. So this makes it like, this is like super easy. We literally just had like one line of code. Really cool. Okay. Now let's do the write. The write should be like very similar and very easy. So what is it? So it's mem copy. So what's the destination?
For this one, it will be buffer.
Yep. Plus.
Yeah, buffer plus 8.
Yep. And then what's the size? Or I'm sorry, what's
our source would be data.
Data, and then what's its size?
Size, I think it would still be chunk size.
Exactly. Yeah. Cool. Okay. So we're done. Boom. MiscChunk is done. And then here's like destructor that just says like, if we've declared data, then just delete data. Cool. Wow. Look at that. We're cruising through this. Yeah. You know what? Let's just like finish these. It should go pretty quick.
Okay.
I'll skip FormatChunk. So DataChunk. So let's okay. Well, let's ignore these. So DataChunk. So remember what things. So yeah, what does DataChunk extend? Do you remember?
It extended. Wait, the data chunk. Did they extend the miscellaneous chunk?
Yeah. So DataChunk basically is a miscellaneous chunk. Like it has nothing else. It doesn't have like int like extra something. No, it literally has the identical properties as miscellaneous chunk. So what we can do is just cast this. So if we say this and cast it, so what should we cast it to? So remember, so this is a data chunk currently according to C++, but it would be really nice if we could just run the miscellaneous chunk things on it. So how can we run miscellaneous chunk things on the data chunk? Like how should we cast this?
Casting.
So what is this? Do you remember?
This is basically just pointing. Well, not pointing. This just is literally what that is when you call that variable.
Yeah. So and what is the type of this right now when we're in this function?
That this is it's right now is data chunk.
It's a data chunk, or it's really a data chunk pointer. Yeah.
And we want it to be miscellaneous chunk.
Exactly.
So does that mean we cast miscellaneous chunk?
Yeah, MiscChunk pointer.
Okay.
Cool. And so now we can put emphasis around this. And so now we want to go and run load on it. Yeah, we just call the load function. We can just do like literally like load. And then what should we pass in here? So we're given buffer and buffer size. So what should we pass in?
Do we just load in buffer
and what?
And comma buffer.
Yeah. Yeah. So this is awesome. So now like we don't need to write any code. We're just calling the function that we already wrote. And so for write, what do you think we should do instead of putting write or instead of putting load? What should we call it?
It would just be write.
Yeah. Boom. Done. These are so easy. Okay. And cool. Okay, let's do FormatChunk real quick. So FormatChunk has a lot of things in it. So it has audio format, num, channel, sample rate, byte rate. Yeah, so yeah, there's a bunch of things that we need to initialize. So one thing that really helps anytime you're dealing with memory is to create a offset. So yeah, to create like some sort of offset value. And so now instead of like just dealing with the buffer value and doing like buffer +4, buffer +8, now we can just do buffer plus offset. And we can think of it as that.
And would that offset be incrementing every time for each those parameters?
Yeah, so let's do the first thing. So we need to load in audio format, which is 2 bytes. So what should we do? So mem copy. So what's the
copy
destination?
The destination is buffer.
Oh, this is load.
Oh, so yeah, our destination would be byte rate.
So first we're going to do audio format.
Oh, okay. So we're going audio format.
Yeah, so audio format, and then we do buffer, and then so it should probably be like buffer like +0, or oh wait, no, I'm wrong. Okay, wait, so this is.
Do we do buffer plus offset for that one?
Yeah, so buffer plus offset, but what is? So here we said offset equals 0, but if we go to like structure, so let's say now our buffer is equal to 12. Because buffer is just like a number, it just points to like where in the file we are at. So if buffer equals 12, but we're saying audio format is right here. So what should our offset actually be?
Offset
here, yeah.
Should be 8.
Yeah, it should be 8. Why?
Because audio format and buffer is at 12, so we had to somehow get 8 bytes.
Yeah,
increment.
Because the chunk ID and chunk size take up the first 8 bytes, and we loaded those with this function right here. So now, so we don't care about loading those data. So now we need, so we set offset equal to 8 because like we already loaded that data. So boom, offset equals 8. Awesome. Okay, and now, and so audio format. So there's 2 bytes in this. So boom. Okay, and are we done? What's the next thing we need to do?
Next one we need to do is the num channels.
Oh, wait, before we get to num channels, what do we do?
Oh, do we need to increment the buffer? No, increment the offset.
So that's one thing, yeah. So offset plus equals, what should we plus equals by?
We increment it by 2.
Yeah, because also look like we're loading in 2 bytes of data, or 2 bytes of data here. Yes.
Okay.
There's one more thing that we have to do. Our bread and butter of loading data.
Converting it to host.
Yeah. So it's equal to, yeah, like you said, so little endian to host. And so is it 16 or 32? Which one should we use?
This one should be 16.
Yep. Cool. Okay, we're done. And so if we want, we could like copy this down a few times and load in like num channels and sample rate and then block align. But this is like kind of getting kind of gross. So instead I wrote a different function right here. It basically just takes all like these like 3 lines and just condenses it into, and it's called load little endian. So the way we do load little endian is we pass in the destination. So audio format, and then we passed in the buffer, which will be buffer plus offset. Oh, no. Sorry, it'll just be buffer. And then we plug in the offset as well. So what this does, so it will load in the data into audio format in little endian format, or it'll load the little endian data into audio format, from the offset, from the buffer at the offset. And then when it's done, it will increment the offset. So let me say it again. So you copy the data into the destination from the buffer plus offset, and then it will go and convert the endianness according to whatever size it is. And
okay.
Yeah, and then it'll increment the offset.
So in this case, since we're only dealing with, so all the sizes and format are just either 2 bytes per bytes. So I'm guessing we have the 2 cases. We have a 2, we skipped 3, so yeah, 4.
Yeah. So we just have this.
If it's 2, it will go to it will convert it with host 16 and then it's for converted with 32. Okay, yeah, that's actually.
And so it's cool that we can just make a few of these. And so now we can just go and copy these. Cool. And now we're done.
That's awesome.
Yeah. Yeah. Cool. So we just always have this offset, and that's always incrementing every time we call this this load little endian function. Okay. And now, so the next, the final thing, oh, actually, let's do the write really quick. So similar to the load endian, I also have a write little endian function. That's, yeah, so it has source and then buffer and offset. So basically it takes it from the source and puts it into the buffer. So it's the exact same thing as this guy, except all of these loads just become right.
What do those T mean right next to the buffer and the buffer in the right in that write function you made?
This is a template. So it means that I can actually pass in if I want. Yeah, so I can pass in like an integer of any size.
Oh, okay.
Mm-hmm. Yeah, okay. So now we're done with write little endian. And so now we just have one more thing that we need to implement, which is RiffChunk. Yeah, which is the actual like riff. And we're not going to do it super true because we're only going to do the format chunk and the data chunk. We're not going to worry about miscellaneous chunk. So let's just do that really quick. So let's just set miscellaneous chunk. Oh, I guess we don't even need to set it. Yeah, okay. So we're just not even going to set miscellaneous chunk because it's a, yeah, cool. Okay. But we need to set format, and we need to set format chunk and data chunk. So what's the first thing that we do? So mem copy.
Mem copy and format.
Yeah, format.
As destination.
So yeah, so what so that's the destination, and then what's the source?
Buffer.
Buffer, then plus, maybe let's do offset again.
Buffer plus offset. Yeah, okay, yeah, buffer plus offset.
Uint 32t offset, and what should we set this equal to? 8.
8.
Because we already loaded in the first 8 bytes with this function. So now, and so mem copy, you can see that it's just an array of size 4. So now we just load in 4 bytes. We're going to do offset plus equals 4. Cool. And now the next thing is...
do we still have to do the conversions for this one?
So we do not have to do it for format because format is not a number. Format is a string.
Okay.
Yeah. So we only do that for objects, not for like arrays. So,
okay.
Yeah. Yeah. So anytime you have an array of data, you don't need to do an endian conversion. Anytime you do it for an integer, some sort of object, you do. So okay. So the next thing is format chunk. So we say format chunk. And we probably want to do like what? So let's see what we have. So we have this load function right here. So how can we load in the data from the format chunk? So yeah, so it takes in a buffer and a buffer size. But can we just do buffer and then buffer size, or do we need to change them? Sorry, yeah. So remember, so currently our offset is at 0 because we're at RiffChunk. But then we say offset plus 8. So we load it in format, and then we incremented it again. So now it's, so now we're at 12. So now the offset is equal to 12. So, but we need to make sure now that we are loading from buffer plus offset.
Buffer plus offset. So do we just do buffer plus offset?
Yeah. And then oh, look, our file is now suddenly like 12 bytes shorter. So now our buffer size isn't like super long anymore because now we're starting at this part of the file, this part of the file. So what should our buffer size be?
Should just be buffer size plus 12?
Ooh, not plus 12.
Or is it just plus 4?
It should be like minus 12.
Oh, minus 12. Okay.
Yeah. Does that make sense? So think like when we say that, so let's say this is our entire buffer. So let's say our entire buffer is 80 bytes. Cool. Okay. Our entire buffer is 80 bytes. But now we go and now we're saying that our buffer starts here. So now we're at, no, we don't have 80 bytes left to spare. If we have 80 bytes left to spare, it would like go down here. So we need to say that it's not 80 bytes, that it's like 80 minus 12 bytes, so that still the file is correctly right at the end of this data chunk. Okay.
Okay.
So this should be buffer
minus
offset. Yeah. And then cool. But so and then now we need to increment offset. And what should we increment it by?
Is it just increment another?
So this format chunk actually just returns the size of this, of the amount of data that it read. So what we can do is just say offset plus equals the size that the load.
Oh, okay.
Yeah. And so now we can do this, except on format chunk, we can call it on data chunk. Boom, done. And now if we wanted to do it on here, so let's go and copy this and put it down here. So what do we do? So one thing like right away that we need to do is probably do these two loads, call them right instead.
Yeah, those are both rights.
Yeah, and then but this mem copy is weird. Oh, this, yeah, and we probably need like a offset. So u 32 offset, and probably equals 8. And so yeah, so maybe this should be like buffer plus offset.
And that one should be buffer, and the other one should be okay. Yeah.
Oh, what should this be?
Should be format.
Exactly.
Yeah. So your format is now the source.
Exactly. Yeah. Cool. So we've finished. So I think watch it like not work, but oh, it won't work. Yeah. error. Okay. This hopefully should work. Oh shoot. Okay. Actually, I forgot about one more thing that we implement. So here, so in this wave load, so now we have this perfectly working like load function that we just wrote. So we can say, so now we're in the wave header file. So remember that the wave file, sorry, the wave like class only has file. Like that's the only member that it has. So we can say file.load, and then we can do buffer, and now buffer size. And now we need to actually go and fill out buffer and buffer size. So, so right here, I created size t buffer size, and this just gets the length of the file, kind of like magic. Don't worry about it. But here we need to actually go and open the file. And the way that we open the file in binary mode is do ifs.open and we do file name. All right. std ios binary. So yeah, so let's look at this. So it says So in file stream, so we're opening up the file stream to now read in whatever file we pass in with this function. And now this file will be opened in binary mode. And that's important so that now every single bit is read as if it's binary and not as text, because some operating systems may convert text encodings. So this just means don't read it as text, just read it as binary.
Okay.
Yeah, and then here, so we need to fill in the buffer. So we can do, I believe it's ifs.read. And it should be buffer and buffer size, I think. Is that right? Yeah. So, and we need to cast it to the point. So read will take everything that is in this buffer and it will just put it in this, or it'll take everything that's in this file and it'll read it into buffer. Cool. Okay. So now we should be done. Let me check. So make cool. Oh, we're so close. I guess we forgot. One. Yes, right here. It should be return. Cool. Okay. And so now I can do /main and do tests and like this one. Cool. And so it loaded in the file. And so now we can see a bunch of stuff about it. So this file, the size is this. The size of the format chunk is this. Here's like all the data. So yeah, it says the sample rate is 44.1 kilohertz. The byte rate is 88.2 kilohertz. The block align is 2, whatever that means. Bits per sample is 16 bits. So we just did it. So this is all from this file right here that we were looking at. So yeah, like, yeah. And if we want, we could like do this on other files. So instead of like this, we could try like this one. Yeah, so now we can see like sample rate is 96 kilohertz and data is like this size. Yeah, and so the only thing that we did not go over is how to initialize the miscellaneous chunks. And that is being a fun exercise for you so right here, so we only worried about format chunk and data chunk. And so we did not try to fill out any of the miscellaneous chunks. And one thing that's a little bit hard is sometimes these chunks can appear out of order. So you could have a bunch of miscellaneous chunks and then a data chunk and then more miscellaneous chunks and then like a write chunk. And then a format chunk. So it makes it a little bit harder, but I believe in you. Okay. And I guess, oh yeah, and I'll give you like a little taste of what the secret file is. Because I hope someone does it.
Secret file.
Yeah. Yeah, let's do it. 80. It's so slow right now. Oh my god. My computer's been so slow. Okay. Secret.wave.
You're still using a laptop, Ethan, right?
Yeah, I'm using my laptop. All right. So here's printing all the data, and then here's some some good quotes that I put in
here. Okay. Let's keep pizza time.
Cool. Well, yeah, that was an introduction to the code. Next week, we will have just like a short class and we'll go over like a few fun things now that you actually have the WAV file loaded into a C++ class. Now we can go and like actually use some fun algorithms, maybe write like our own audio effects or whatnot. So yeah, I look forward to the final
Okay.
in binary hacking next weekend.